So this is installation and commissioning safety. Okay, so we've got Stephen Rose, Head of Completions and Commissioning at SSE. We've got Graham Hogg, Senior Electrical Engineer at Excel Tech. Okay, Mark Ajal, Head of Commissioning at SSE Renewables. Thank you, gents. Okay. Okay. Stephen, you're going to take the lead on this one. Thank you.
Right, good morning everyone. Thank you for coming back so swiftly. So my name's Stephen Rose. I'm the Head of Commissioning for SSE Renewables offshore. Been in the industry lots and lots of time. But the reason I really came back here, and it's just a short story, I'm going to ad-lib on this, probably about 25 years ago, about 10 miles north of here, I was a third engineer in a D&O. Done lots of authorised person training with a whole bunch of new technicians that we'd employed for the old Eastern Electricity. Thought we'd done a stunning job, 5 guys, 5 vans, 5 tool sets, going out there looking after LV faults, no supplies, until I got a call, unfortunately, can't remember the day now, that one of my guys had suffered quite a serious injury, and he'd basically been putting an LV fuse back in an old metal-clad substation cabinet, if you like. And something had gone wrong. To this day, we don't actually really know because there wasn't much left of the cabinet, but he'd got some fairly serious arc burns to his chest, to his hands, to his face. Now this was early 90s, I should think, so before Scanware, BS, before Scanware. We'd just invested in overalls, but we'd found some nice corporate blue overalls, gloves, visors, arc protection, calorific values, all something that was unknown to us yet. So we thought we were doing the right thing. But I promised to myself then I would do everything physically I could as a supervisor, as a manager, as a coach, to make sure I never had to visit anyone in hospital, anyone's family again. And it was a long trek, a long drive from Norwich to 2 hours to go and talk to his missus that I'd met a couple of times because I'd stayed around her house. So just one thing to bear in mind, as a manager, senior engineer, if you're responsible for people, do anything you can to avoid that conversation, because it's probably the toughest thing that you'll ever do in your life. Okay, good. Thank you. So I'm going to take you through installation and commissioning with my 2 colleagues, Graham and Mark, today. I like to think this is the sexiest bit of project work, basically. Construction, have probably been there, hopefully still there, not gone. But we get to commission, test it, we get to turn it on, watch the needles move, watch some megawatts, watch some volts, and then we get to clear off and bung it over the fence to operations. At least that's the story anyway. But I'm going to take you through a couple of things we've learned in the last 4 or 5 years through completions and commissioning on some of our big offshore wind projects. So the first thing is a completions process. I'll just ask a question here. Who in the audience actually runs a completions process? Now, not just completions in a contract, but I mean a physical piece of software, mechanical completions walk down, that kind of thing. Just show of hands, who's got a completions process? Yeah, 2 or 3. Well worth a thought about this, and the whole reason we're doing this basically is from a safety, health and welfare point of view, also to keep to a schedule, which makes the finance people happy, makes your investors, makes your stakeholders happy. The aim is once we're on, we stay on, okay? So I work offshore. One of the issues we have, if we have significant punch lists of items, significant defects, that means I've basically got to put a small team of people up a turbine, so that's a climb, a marine transfer, got to get the right tools, a safety document, a climb up the turbine, a repair, and back down and repeat. Most of these wind farms will have 100 wind turbines or so, some more, some less. So if I have the same defect on 100 turbines, that's 100 jobs that I'll have to do. And that might just be a rusty hinge, it might be a seal on a door, or it could be some electrical component cables that we've got to retest or re-terminate. But every time I have to set someone to work, that's one more opportunity to get something wrong. Okay, it's one more opportunity for someone to get hurt. So back to my point earlier about health and safety, I'm not going to talk about arc flash electrical safety type issues per se, but this is talking about cutting down on work and making sure we do things properly. What is a completions process? So you see on the left hand side there, completions system. So we track all of the plant and equipment basically to make sure when it's installed, when it's constructed, before we get to the commissioning stage, that it's actually what we asked for in the contract, what we purchased. So if you asked for a grey transformer in a shed with all its instruments, making sure that's what we've got in front of us. But it also includes the gates, the civils, the buildings, the electrical infrastructure that we fit out in the substation. So a typical offshore wind farm, probably 70,000 components. So my team, what they're going to do is physically check pretty much all of those 70,000 components and make sure that it's fit to turn on, fit to energise, so we don't pass a whole patch of defects onto the operations phase. And that's where it comes into the electrical safety. We'll also be making sure that from an asset integrity point of view, that it's safe to switch on, it's safe to generate, and it's going to be there for 25 years. I used to work in the operations team, so I know what bad construction, I know what poor commissioning looks like, because we've suffered from that from a few projects. So having to come across to the dark side now of construction, and I bring some operations knowledge to us, and what we're trying to do is to cut down that extra work so operations get what they need to have for that generation site to be in full production, and also to cut down on any issues. What's involved in mechanical completions? So systemisation. So the picture on your right is an onshore substation there, and you can perhaps just see the Harris fencing around those cable terminations on the left. So the reason we break that wind farm down of 70,000 things, we're not going to turn it all on at one case. It's not a case, as my finance director thinks, of a light switch that you turn it on at the national grid end and something miraculously happens offshore. We break each of those components down into a system. So onshore substation, converter station, AC, LV, balancer plant. And then once that's systemised, we can break that down into nice manageable workable chunks to do the completions walk down, to do the site acceptance testing, to do the integration testing, and then eventually to come through to commissioning. Tagging, really important. Who's picked up a drawing and you find it's not the tag in front of you, or the tags change halfway through? So now we have a tagging system that we use with an SSE with offshore that goes all the way back to the design stage. So when the people are desktop engineering and they've got a 12-point tag, we start to call it that from the first drawings, from the first engineering studies that are done. So that tagging system flows through from development through to design all the way into operations. Not always perfect, but that's hopefully the goal we're going to make. Verification and validation. That's our engineering team making sure that what we've asked for, the specifications, the employee requirements that we've asked for, is what we actually get delivered and what's installed. The factory acceptance testing and the punch lists are really key item so that we know when our goods leave the factory that it's tested in accordance with, again, our contract terms, with some of the specifications that we've asked for. We start to create punch lists then. Really important to collect those defects, collect those things that you want addressing before you commission, before you go into operations. So the completion system helps that by collating all of that information. And really importantly for us, that means you've got one source of the truth. Okay? So rather than having packages saying we're defect free, we're ready to turn on, okay, you can say, well, actually, you're not. You've got 2 or 3 Class A defects, you've got 10 Class B defects. As a commissioning team, we're not turning it on until you get rid of the A's. Okay? So that's the power and the authority that having a good completion system and having a commissioning team hopefully can bring to a project. We look after TQs, we link into quality assurance, and typically on the installation and construction work, all of those systems will flow through from first installation at civils, installation of the large mechanical items, transformers, concrete beds, all the way through to the cabling to the LV side. Okay, so everything's included. Ready for commissioning. Now, for my colleagues from Equinor are here, we did actually steal this from our joint ventures partner. And perhaps the other key thing I'll take away is we're always learning. So I've got to perhaps to the grayer end now of my career in offshore wind. But every week, every project, we learn something. Whether you learn it because of something that went wrong, or whether you learn it from your joint venture partners or your contractors to new people coming through the industry. Okay? Always be open to listen and learn. And so we picked up this completions process somewhat late in our lives as a DNO. We only started running this around about 3 years ago. So what we're looking for at the ready for commissioning stage, we're looking for installation is complete. Installation test reports are all received to us. In the old way of things, we would receive all of our documentation around about 6 months after completion. That's not very good for the operations team because they need to know how to operate it, how to maintain it. Okay, so we've brought that forward now. Until we get our plant and process information, you heard my colleague Mark from SSE talking about that earlier on, all of the information to make sure we can commission and operate this plant safely and adequately. Our teams are trained, and that includes arc flash labels, things like that, making sure that comes through into the stage before we energise. Preservation is complete, so if there is early maintenance, so electrical equipment that's being sent from around the world, literally we're bringing stuff in from Korea, from China, Eastern Europe, from America. Sometimes that's in storage for 6 months waiting to be installed. Very often that needs to be installed in clean, dry, warm conditions. If it's left outside, it's going to start to deteriorate. If it's electrical goods, we all know what happens when electrical goods start to deteriorate and they get damp. Yeah? It's usually not very good. We go through factory acceptance testing, making sure all the test reports are received and they're signed off. But I was going to say, what else comes within ready for commissioning? We like to think offshore that we're slightly special, and there's an offshore rate for everything, usually about 10 times what it is for onshore. But some of the other areas that we have to consider is logistics. So the picture on the right, that's our offshore substation at Dogger Bank, 9,000 tonnes, 320 kV. We've got 3 of those installed now. To commission it, we have to have a jack-up. That's there for 90 days. So we live there. We take helicopters backwards and forwards to get to work every 2 weeks. The guys and the girls go through an inordinate amount of, you won't believe it, salad. They use an inordinate amount of batteries, toilet rolls, everything that you need at home for your weekly run to Tesco's. We have to get out there every 2 weeks. So we have to keep the teams running. We have to keep them safe. We work within a framework of CDM, which can be quite complicated sometimes. So a principal contractor, not always us as the client. Sometimes we'll have our principal contractors will be one of the main installation contractors. Sometimes they won't have a high voltage safe system of work, so we have to implement that literally under someone else's umbrella as PC. So that takes quite a little bit of work and support and communication. Welfare, electrical safety, quality regulations. So for onshore substations, before we energise and commission, we have to make sure that the fencing is complete. No one wants kiddies, we want wild animals, but we don't want other contractors, people getting onto a substation site that we're about to energise and just walking into what is potentially going to be a live area. So making sure that all of the civils are done, proper warning signs are up, we've got security, CCTV, all of that infrastructure again comes under the commissioning ball to make sure that that's ready. And more than ever, I think every week we hear of someone being hacked or cybersecurity. There's a lot of actors in the world that would like to turn our lights off. We saw the damage it did a couple of years ago in London where we lost trains, we lost hospitals because a power station and a wind farm tripped at the same time. Had some remarkable effects. Thousands of people stuck on trains, operations not happening in hospitals. So we also have to make sure that cybersecurity and data protection is looked after. So all of this we have to bring together somehow before we even ready to energise. Ready for operations is the next phase. So having been through all of that, making sure we can actually energise it, we've actually now turned the thing on. The types of information that we're looking for, the life cycle information, so maintenance drawings, red line drawings to make sure they're ready and issued and published to us. Strategic spares have been delivered such that if we have some sort of failure on the equipment, that we've got a spare transformer, spare cable, spare circuit breakers, spare blades, whatever it's going to be, they're in store and ready to go. Familiarity and training for O&M. We always try and make sure that the O&M team are involved in commissioning. So if we're good at our word, and once it's on, it stays on, they've got a one-shot opportunity to work on some of this equipment before it's energised. Because once we're energised, we're not going to bring it off for any particular good reason. So having the operations team there alongside us to help with commissioning is really quite important. The OFTO regime, so we work under strange times with OFTO, I don't know if there's any OFTO partners here, but we take our transmission asset from the onshore substation to the offshore substation. Once it's commissioned, once it's ready for handover, that's sold under a regulatory regime to a completely different company. So for me, it's like buying a new car and then someone takes the wheels, basically, so you're not too sure if you can drive it or not. I would much rather keep it myself, but we've got the OFTO regime, we've got some really competent companies that will come and they'll asset manage the transmission. It's vital to me because that's my route to market. It doesn't matter how good the wind turbines are at generating, what the availability is. Without transmission, without the OFTO partners doing their thing, then there's no route to market for me. We don't make anything. The meters won't spin. We make sure that in that interim period, which can be 12 to 18 months to handover, everything's been maintained or has been preserved in accordance with the OEM's instructions. And also then energisation, hot commissioning, all taken part, and any ongoing integration or performance testing. So I'm sure everyone who's looking after whether it's solar, battery, wind, hydro, data storage, you'll go through some sort of performance test that you have to prove that the systems you've installed are all working according to your employee requirements. That in itself, you might have to wait for weather conditions, you've got to wait for a windy day, all the turbines to be running, for the sun to come out from behind the clouds, for the perfect conditions. So that doesn't happen every day for us. So again, generally not during the summer, but we're looking towards the winter months when we complete our performance and site integration testing. I'm just going to go aside now and talk about a few other processes that we use. None of these particular come from SSE. It's not something that we've dreamt up ourselves. Rehearsal of concept or a rock drill, that was taken from the military, basically. So if anyone's watched some of the films and you see a squad of soldiers before they go out on a mission with a sandboard, making a pretend village, little toy soldiers, bits of string to show minefields, that kind of thing, then we use that concept called a rehearsal of concept drill, to make sure that we plan and we ease out anything that could go wrong. So we practice that, basically. So what that involves, as you'll see on the picture on the left, is all of our contractors getting together, all of the package managers, the commissioning team, the safety team, our SHE team, and we'll actually do a dry run of installing an offshore wind farm. It's marvellous, we use Lego boats, we use cotton reels, bits of string, anything we can get our hand on, but for around about a day, we go back to our childhood and pretend we're building an offshore wind farm. Now typically out of that, you might find 50 to 100 actions, things that you've forgotten. Where are the toilets going to be on the substation before the lights come on? How are you going to get food out to the guys if they get stranded on a wind turbine? That kind of thing that we'll rehearse and go through. So another useful element to make sure we get it right. But that rock drill can also encompass health and safety. So the chap in the middle there, this was the first offshore wind farm that we had where we had to get helicopter travel out for when we were working offshore onto the vessels. So it meant that we had to have some slightly different PPE, the same stuff oil and gas use basically, but as a offshore wind team, new to us. Lots of suppliers promised the earth from their PPE, so I can go and buy this and I can go and buy that. But PPE, as you'll know, is a system, so it's all got to work together. So if one of these people then falls off the boat, falls off the gangway, we really need to know that it works. So your flotation suit, your life jacket, all measured for a certain weight. As you can tell, I'm fairly top heavy, unfortunately, so I have to be really careful when I put my harness, and I've got bags and bits and pieces on, that my inflation device will actually work and it'll right me in the sea. There's only one way to do that. Don't trust your contractors, don't trust the slick salesman. Sorry guys, they're all pretty good. But we threw the guy in there, put his PPE on, bought a couple of sets, and we go throw him in a swimming pool basically, put some waves on and make sure all his stuff works. Okay, underneath there will be all his ARC overalls as well, adds to that, because as soon as he takes it off, he's potentially in a live substation. And on the right-hand side of that, for those that do actually know me, then I also volunteer for the ambulance service as well. So for the last 5 or 6 years, unfortunately, I have to attend in a green suit and come up to several industrial incidents and looking after people. Really important as part of those rock drills and practices and rehearsals that you can look after your team offshore. So this is on an offshore substation. Jack-up is there. Medics on the jack-up, probably about 10 minutes away by the time you've worked your way out, put your PPE on across the gangway, walked up 2 or 3 flights of stairs. The substation's that big, you have to have a map, basically, until you're familiar with it. So part of our rehearsals and our practice was to make sure that if someone went down in a substation, so this was actually an electrocution and a burn for this casualty, in a live room, to make sure that how we're going to get prompt medical aid to him. And from doing those drills, there's some interesting things come out there, basically. We suddenly realised that we needed better first aid equipment, enhanced first aid equipment on the substation, because it takes too long for the medic to get off the boat and come and help us. And we also worked out that the first responders that we have out there, the people who are working in that team for those first 10 or 15 minutes, called the platinum 15 minutes, when you have to keep someone going till a medic gets there, they needed some extra skills and some extra equipment as well. So that's a rock drill that might be interesting. Process mapping and playbooks. So this is my 5th offshore wind project in SSE. I know it probably doesn't look like it, but that definitely has turned me grey. What we found was on the 2nd and the 3rd project, then it typically goes in a cycle of boom or bust. Really, really busy, then nothing happens for about a year. New project kicks off and we all mobilise and start again. A lot of the people will have moved projects, a lot of our contractors move on. We'll have new OEMs, new contractors joining us. So you're kind of learning some of the lessons for good and bad each particular project. It's a bit like Groundhog Day for everyone who's watched that. What we didn't have in commissioning and completions was a set of common processes. So we listened to the voice of our Tier 1 contractors and Tier 2 contractors, said, whenever I come to one of your projects, Steve, it's a slightly different set of safety rules. I wear this PPE there, and I wear that PPE there. So it makes it a little bit difficult. So we came up with the requirement, basically, to get all of our processes written down. So wherever I go in the world to commission an offshore wind farm or a substation now, we pretty much follow the same storyboard. You'll have heard of process mapping, a workshop with the team, and what we're trying to do is get the knowledge out of their heads, getting it converted into something that's written down. We were writing a lot of PowerPoint, Visio, process charts for anyone who's been involved with that, which would have then sat on a virtual shelf on SharePoint, perhaps never to be read again. We went out to the market, and there's a chap here called Pip. So if anyone's remotely interested in this stuff, it's a really interesting discussion. Go and speak to Pip, shameless plug, sorry, we'll charge him later. So the picture on your right is Method Grid Playbook. So rather than having lots and lots of Word documents, operational procedures, PowerPoints to try and get your new team as they mobilise, as you train new commissioning managers, new commissioning engineers, new SAPs that are all coming through into a growing industry, then we use this tool basically to get all of the knowledge into one place and to share it with new teams. It also includes some element of tracking actions and making sure that we're doing the same thing, good or bad, to the same people for the same project globally, which is really important for SSE because we're now expanding from UK through to Ireland, through to Holland, Japan, Australia. We don't really know where our next project's going to be till it gets signed, but we're going to be operating somewhere else globally, which is a whole new set of challenges to us. And that comes to the end. Why have I gone on about completions and commissioning? Because I believe it's a forgotten step in developing a project, in taking it from construction to operations. A lot of the commissioning managers are getting to the stage now where they're approaching retirement. We're not bringing enough people in to backfill us. So the whole point really of the completions process is to standardise that process, make the plant and the equipment as ready and as safe as it possibly can be to energise, to pass it on to our operations colleagues, who will be a very new team themselves, making sure that the commissioning team are involved, and we listened to that design stage previously, and I think we go back through there later on this afternoon to make sure we get an input, so to make sure that the site is safely operable, but also to make sure we can be commissioned safely. We have an input into the contract scopes in procurement. So some of the specs we heard about Lotto, making sure that equipment can be safely energised, but also it can be safely isolated. And you can go through your Lotto process. Making sure that we've got adequate commissioning plans, months in advance of actually turning something on, not just picking the phone up and say, guys, we're ready, can you come along next week, which I'm sure we've all heard before. And the last part, that rehearsal of concept drills, that I think is a useful tool in anyone's armoury of getting the project right. So that's it for me, thank you. Hand over to Graham. Oh, there you go.
Thank you, Stephen. My name is Graham Hogg. I am electrical engineer and company director of my company. We're a small installation and commissioning contractor. Tend to work on chemical plants, gas sites, places like that, all over the world. And my section, to pick it up basically on Stephen's part, is this is actually, all the photos were actually taken last week of a site we're currently working on. So, in installation and commissioning, this board's not live, it's not been turned on yet. We are actually practicing isolation schedules, switching schedules for want of a better word. And this was actually a particular interesting slide. I sent this one to Angus just, I think it was Friday. We were practicing switching schedule and we noticed a bit of a design flaw with the switchgear. Once I racked that particular circuit breaker out, we can't lock the door. So things can get right the way through production, FATs, installation, and right at the last minute you can find things are wrong. We still haven't decided what we're going to do about that yet, but one of the things we did do was we practiced the switching schedule, but with a PPE on. And we did that so we know that that task could be done ergonomically wearing that equipment, or we have to buy some new equipment, different equipment, could have been different gloves, could have been different tools, different procedures, or rewriting of the schedules and finding a different way of isolating that particular piece of equipment safely. Where have we jumped to there? Oh, yeah. So, safe isolations, planning and implementation. A lot of the sites I go on to are historic sites, they're upgrades. And when we get there, we inherit clients' lockout, tagout procedures, I suppose, or equipment. And a particular site I'm working on, this was the lockout cabinet. Very well made, joinery, but it's from about the 1940s. So before we start commissioning, and it's years in advance, sometimes months, we've got to make sure we've got all the right equipment. And when we, let's say this particular site is a large upgrade, so a lot more switch gear is going in, and a lot of old gear, is we put new lockout cabins in and train all our guys to suit, and then also bring the client team up to scratch and start removing this, upgrading the procedures, the policies, and also training their operational staff. Because once this was fit for purpose, it no longer was for the new system that we put installing. Also, something that gets overlooked, everybody thinks commissioning is new equipment. It's not always. It's recommissioning, repurposed equipment. And this was taken last week, and this is a board I'm about to bring back online. It's had a few instances over the years, but that whole particular board is getting recabled back to the control system, the DCS, and all that's got to be tested and recommissioned, all while it's still live. And we've got to prove that that is fit for purpose, because the desktop engineers, they might send us a design and think that you can connect to it, but we've spent months on this thing so far, and the internal wiring of that was nothing like the drawings we were sent. Nothing like it at all. It's the old rubbish in, rubbish out. So the client sent the EPC contractor all the drawings that they had in their archives, and while them drawings might have been right when that board was built, there was years and years of change unrecorded in this. So we've basically reversed engineered that and brought the drawings up to scratch and then reprove with the EPC that it's still fit for purpose, or come up with new work packs and get this thing rewired. And those are, I always find those are the more high risk activities because you just don't know the status of that equipment at all times. So when I'm going onto these sort of sites, who's responsible? Well, unfortunately, my clients tend to bring me in to be responsible on their behalf. So I am that site's SAP now because they didn't have anybody. It's contracted out a lot. So with the client, we'll take ownership of their system and train up the new guys as well. So it can be a lengthy process with the clients of getting them to understand what their responsibilities are, especially on some of the sites we go onto where they bought out the historical. I mean, that site I'm working on, there's 150-year-old, and it's had numerous owners. So they all just keep inheriting old ways. So this one has been a particular challenge, and now the client's on board. We've got new safety rules in place, we've got new authorisations, and a lot of training ongoing with their own people and the contractors as well. So competency in electrical safety, this, again, I think we've already touched on all of this training and stuff, is training up the new guys, what certifications required. It's a long process with the owners to list out what is required of every single person within the authorisations and bringing them through it and practicing it. So before we switch this thing on is making sure we go through drills, as Stephen touched on, and make sure everybody understands the schedules, the rules, the permitry, and the operational permitry once we step in or go into place and we come out of CDM, because the CDM permitry is very, very different to the operational permitry. So, short and sweet, and with that I'll hand over to Mark.
Good afternoon all. My name is Mark Ajal. I work for SSE Renewables, taking care of the onshore commissioning. Steve takes care of everything offshore, and we deal with all the technologies onshore, from the old hydros, some of which are more than 80 years old, to brand new wind turbines, to solar and battery technologies. I'll focus a lot on the technologies that involve conversion. The first session we had this morning, Mark Patterson mentioned, I think it's still here, Mark Patterson mentioned we can pay attention probably 50 minutes, and after that we are away with the ferries or we're simply tired. So because we've been seated for exactly 35 minutes, I'd ask that we engage the audience a little bit. Look around, you'll notice some wood carvings, the motifs on the wall. Tell me what names you see, because we are hosting this event at the IEC. What names are on those motifs, and what comes to your mind as someone who works in electrical safety? Could have some audience microphones, please? Yep. Any takers? Yes?
Yeah, so if you look over there, you'll see Faradays, you think of capacitors. So for electrical safety, first thing that will pop in my head will be shorten to work on them.
Thanks, Joseph. Keith? Any other contributions? Yes, sir? Yes, Ampere. Very good. Maxwell. Fantastic. There's a Faraday. There's a Voltaire somewhere. Lord Kelvin. Yes? Voltaire, yes. So we're in a room that's full of history. This event is being hosted at the IIT. Why do I start this session like this? It's for one reason. In the world of electricity, all we are playing with is energy conversions. We are going from a solid fuel to electricity. That's nuclear, coal to electricity, lignite. We're going from a liquid fuel, HF4, crude oil, diesel, petrol, to electricity. We're going from a gaseous fuel, our CCGTs, taking natural gas and turning it into electricity. The emerging technologies are taking hydrogen and turning it into electricity, or taking solar radiation and turning that into electricity, or stored chemical energy in batteries and turning that into electricity. Why do I say that? Some of these energy sources that we're dealing with on emerging technologies cannot be switched off. If you're looking at a solar farm, the moment those panels are exposed to the sun's irradiance, it's live. There's an open circuit voltage with a certain minimum watts per square meter irradiant on the surface of the panel. You can't switch off the primary energy source, which is the sun. So where do you take your safety into the rest of the conversion system? Another challenge that we face in emerging technologies, grid codes were traditionally written for the traditional power conversion systems, coal, gas, lignite, hydros to electricity. Grid code definitions sometimes don't fully capture the essence of dealing with DC systems. In other cases, safety rules of different companies, it's a global conference, would touch very heavily on the AC component. There might be IEC standards that deal very strongly on AC, but perhaps are thin on the DC side. You'll find language like not exceeding 1,500 volts, and then exceeding 1,500 volts. That 1,500 volt threshold becomes your HVDC limit. Below that is LVDC, above that is HVDC. Do your grid codes capture that in the jurisdictions you work? Do the safety rules for the organizations you work for capture those nuances if you're having any DC systems? Then within a battery facility or within a solar PV facility, because of irradiance hitting different panels at different points, or simply because of the way the batteries are wired, you try and wire them in a string, so a sequential string, where the voltages are additive. It's a numerical addition. One string plus the other gives us the total voltage of the bank or of the PV array. There'll be a delta. You'll not have a consistent voltage. So those voltage spreads mean if there's a voltage difference, current is flowing. The other bit is on PV modules. As irradiance changes, sometimes within seconds, suddenly you've had a sunny day and you have a massive bit of cloud cover. That change from the primary energy source means your conversion is giving you different spreads of voltage within the facility. I've included something around a data sheet of a typical PV module. And this bit, these coefficients, the temperature coefficient of our open circuit voltage is an inverse proportional value. That creates a problem for us, which we need to deal with from a design perspective, which is you need to do temperature corrections for open circuit voltage. And you do those corrections for worst case combinations. So you've got an inverter, 1,500 volts. How many strings can you connect so that you don't exceed that voltage? It's not a simple addition of the strings. You need to calculate. There are 4 methods. I'll not touch on them in this, but we can have a session later where you do worst case combinations. What if we have this level of irradiance and the temperature drops? What impact would that have on my open circuit voltage? Those calculations help you determine how many strings to connect for the modules and how many strings to connect for your batteries. But it also helps you with specifying your inverters. So the inverter manufacturer will guarantee this inverter is safe up to this number of strings. Then the selection of materials, low smoke, halogen-free cables. That's what we use, the H1 Z2 Z2K for PV strings, and it's 4 square mm, 6 square mm or higher. And then the connectors. Since you can't switch off the primary energy source, which is the sun, you deal with insulating into the conversion side, which is where your MC4 connectors come in and don't allow you to come into physical contact with live sections of the system. Then on the inverters, manufacturers may state the inverter can handle up to 1,550. But in service, safety measures kick in. At 1,500 volts, the inverter stops running. The internal circuit breaker disconnects, And other DC components, if, like Joseph mentioned, if there's a potential of an overcharge from built-up charges, they'll handle up to that 1,550, but you're not operating the unit in the high voltage DC region. The other bit that I'd like to touch on is on batteries, in the few minutes that we have left. So for batteries, if you're going into battery technology on a utility scale, it's important, very important, that you do these elements. Engage your supplier to make sure you have a hazard mitigation analysis, your failure modes and effects analysis, your fault tree methods, and then in the construction. Some of these studies you'll actually need as part of the planning permission to your local planning authority. You won't get permission to build the consent that you need from your local planning authority without some of these studies. But in the construction, be careful that you're not replacing DC fuses with AC fuses. Some modern, a lot of the lithium-ion batteries we get have water cooling. So water tubes circulating, uninsulated, but carrying away the heat. Remember, we're dealing with a joule heating issue, carrying away the heat from the batteries and having that heat dissipated. And then within the enclosure, have sensors to pick up anomalies where the rise up of certain gases tells you there's a risk of an electrical incident happening. You have your hydrogen sensors and your carbon monoxide sensors. There'll be sounders and beacons that would operate just like a fire alarm for a building in this kind of building. Your climate control systems helps a lot with preservation. So from when the units are shipped from the factory till when they're placed at site, till when they're ready to be turned on, are they absorbing moisture? If they are, what are you doing about that? Is that creating a potential risk that when you start up the units, that fast electrical energy passing through them will cause a disruptive failure? How are you preserving the inverters? How are you preserving the power conversion system? And then modern batteries have deflagration panels, which basically says it's explosion proof. If, in the worst case of set of circumstances, you had a thermal runaway event where all these about 7 layers of electrical fail-safe systems have not done their work, which is extremely unlikely. If, in the worst case, all 7 stages have failed, the panel should be able to contain that explosion without damaging adjacent infrastructure. And that's both the infrastructure and electrical protection. So the other bit I wanted to discuss around electrical safety is around operatives. My background is testing. I'll be very quick. Are your operatives trained to operate that test set? The device under test, is it ready for testing? If you can find the best quality instruments that are fail-safe, it's a big protection for you. And the SIGRE standard 697 helps when you're dealing with HVDC. If you can look through it, it does help with setting up what's the purpose of your tests, the preconditions, the procedure, and the acceptance criteria. And that's the end of our presentation.
Thank you, Mark. Thank you, Stephen. Thank you, Graham. Good presentations, I appreciate that. We've started to get some of the Slido questions coming in, so as we sort of said earlier, as everybody coming back from the break, there's some questions putting on there. If you've got some questions, please post them on there. If there's a question you want asking, like it, give it the thumbs up, and we'll ask them a question. Okay. A lot are coming around commissioning at the moment. Stephen, I'm going to throw the first one to you. And it really challenges that competency. How do we manage competency around commissioning engineers? It's hard to get commissioning engineers. How do we manage it? How do we build that competency in there?
Okay, I guess I can really only sort of talk from experience we've had from SSE. We're a big company, D&O heritage, so we work to transmission and networks line. So a lot of our processes, procedures, we're really fortunate to have a training school, 2 training schools in actual fact in the UK. So we do bring through an awful lot of graduates, apprentices, and they'll all be time served. They'll move into generally operational type roles, engineering type roles. So we were challenged probably about 4 years ago, and remember I told you about that hurdle of on-off project. We were always using contractors for our commissioning teams, and the issue we had was they would generally leave before commissioning had finished for the next project for the next couple of years. So our challenge was, and we formed a staff commissioning and completions team, and what we did for that was to bring through a lot of people with the good operational experience, time served, but we also have a process of mentoring. So we've got a team of 50 odd commissioning completions engineers, including SAPs, half staff. I would say of that half of staff, half of those people we probably regard as new entrants to the industry, and we go through a process of mentoring. We'll bring those people through into the commissioning teams. They'll follow the projects through for a couple of years. The next project we do, we might bring them through in a slightly different role, so they'll move from SAPs to lead SAPs, from commissioning engineers to lead commissioning engineers to commissioning managers. So we always try and have new people coming in, mentored, and show them the development route so we can keep them. And in actual fact, I'm going to point out Joe. Where's Joe? There he is. So the chap over there, nicked him from National Grid, I think, started for us as an SAP, a lead SAP already. And I have no doubt that he's going to be a commissioning manager of the future, which is why we're doing some of the things we talked about with the playbooks, with process mapping, having completion system. Everything we do now really is to prepare for the likes of Joe coming through into the industry.
Mm-hmm. Good.
But we're fortunate, we're a big company and we can do that, and I fully understand the struggles of companies that haven't got that luxury. It's tough.
And I guess one of the follow-on questions from that is asking, is there a professional organisation that looks after commissioning engineers and commissioning managers? But I suspect from what you're saying there is probably not.
Not really, no.
No.
I guess to be a commissioning manager, you have to have a little bit of everything. Some background in operations, certainly some sort of previous management experience, especially for offshore. You'll be managing logistics, recruitment, health and safety, so we have to have key skills of sort of health and safety advisor. We'll always have some sort of NEBOSH to fall back on, so we've got a basic fundamental knowledge. There's, for anyone who's on LinkedIn, I think there's one organisation, Commissioning CX, based out into the States, that you can join, but yeah, APM or IET is your best routes through to sort of keep up to date, and then learning with a personal development plan, much as you say everyone else has.
Okay, good. I think the next one's really for you, Graham. So that commissioning ensures all equipment is labelled correctly. This is done for the front of switchboards, but not always for the rear. Do you think it's necessary?
Yes.
Yeah, to me it was a yes. I'm a little bit surprised at why we aren't.
Yes.
You know, the labels don't cost much, do they?
As we take switchgear from the construction teams, it might not be labelled, but it's something we will do in pre-commissioning, is we will walk right through that system, and something we were doing in the photos actually, as we're walking through the switching schedules, is make sure we can correctly identify we are on the correct part of the system at any point, front, back, cable entry box, it doesn't matter. I've worked with some clients where it'll have its K number, KO1 say, but they also use symbols, and they'll put symbols within their switching schedules, so it'll be a red star, and then it's a blue circle, and it's just different indicators different companies use. But yes, right at the backs of compartments, we label them all up.
Label it all correctly. Yeah. Simple. Labels are cheap.
Yeah.
Exactly. Mark, you mentioned a bit about H2 or hydrogen and CO sensors. Do you think that now falls into the ATEX Desir type world for these battery systems? How do we manage that?
Well, I don't know if there are any battery manufacturers in the audience, but it's not necessarily the ATEX environment, because that's very heavy on the hydrocarbon industry.
Absolutely.
However, because there is stored energy that's sitting there with, we're getting battery containers, 20-foot equivalent or 40-foot equivalent units that are up to 6.25 megawatt hours of stored energy in a single battery cell. So there'll be levels of protection, but we still monitor the same way you'd monitor, you'd have thermosensors in a room like this. So you treat it almost the same way you treat a building, a facility that has people going in and out, but has heat as a constant outcome of its operations. So you monitor heat levels, but you also monitor the rise of gases that would be indicative of a disruptive failure is starting to build up, and then the units would either protection systems would operate and isolate that section of the plant, or alert a maintenance team. I'll give an example from a very recent project we've worked on, where these alarms and actions coming out of the plant are built into the signals that we take into a remote control center. So our SCADA traffic carries alarms and signals, and within the control room, we'll write a control and operations overview and an alarm actions document that says to the controller, for this alarm, this is what you should do. And we try and have plant automation act independently of a control engineer, but if in the event that automation systems don't kick in, a control engineer has access to an alarms and actions document that will tell him, for this alarm, take this action, and you'll keep the plant safe.
Good. All right. Here's a good one, and I'm going to throw it open to all three of you. How do you persuade upper management that thorough commissioning is critical, while they may have a great focus on that schedule, production, and contracts? It's that balance, isn't it?
Well, I'm a contractor. So I have clients and I deal with management quite a lot. They don't always like to hear it, but it's obviously just walk a client through it, explain the whys, and that they've actually contracted you to do a job and do it safely. And if they want me to do my job safely, they let me do it. And this is how long it's going to take, this is what I need to do it, and the why. And most times, project directors, things like that, are from an engineering background, and they do understand. Yes, there will be a bean counter somewhere that doesn't like schedule impact, but it's better it's commissioned properly now than it shuts down and doesn't produce ever, isn't it?
Yeah. And Stuart, I could also share a mantra that I use a lot is, once we start working on systems that are live, whether it's live at 240 volts or live at 400,000 volts, we prioritize momentum over speed. Mm-hmm. We'll deliberately go slow to keep progress. So double check everything. The jobs are planned well, the operative is in the right state of mind. And from an institutional perspective, in the UK, legislation is very, very strict. So for most clients, or for most employers in the UK, the law will force a certain behavior because the consequences to the asset owner are significant. It might be different in different parts of the world, but this is your asset. You've sunk whatever amount of money you've sunk into it to get a return for 20, 25, 30 years. What is an extra 2 or 3 days of a safety process for an investment that you'll earn from for 30, 40 years?
Exactly. Okay. And I guess going back, and I think you maybe you mentioned it, Mark, is there any ISO documentation or standards that cover commissioning?
Yes, SIGRE TB697 deals exclusively with HVDC commissioning. When we go into the IEC suite of standards, we'll find a lot of things around specific pieces of equipment. Mm-hmm. But I'll put a disclaimer and say standards don't give you pass and fail criteria for everything. In some cases, they'll tell you, this is what a good test setup looks like, but the interpretation of results is sometimes left to the judgment of the organization. What do you accept as an organization for instance, an acceptable level of insulation? Some standards, some of the IEC standards, are very clear around 0 PD for rotating machines or 0 PD for cables. Other standards will tell you, do a baseline at the factory so you know this is what the sweep frequency response analysis looked like at the factory, and then you can baseline off that in year 0 at commissioning, then subsequently during the maintenance phase. So there are standards. Interrogate your design teams, reach out to the standards, and we can have conversations after this. There's some standards, but standards are not prescriptive for everything.
Okay, that's good. Sorry, go for it.
Yeah, so this is a question for Graham. So you spoke about the difficulty of large old-scale retrofits when going into large clients' projects, and sometimes the physical reality doesn't match with the documentation that you've been provided. Can you talk about the process that your team goes through to identify the issues or deficiencies in the documents making sure that you guys have documented those changes of what's actually there, and then providing that information back to the client so that they can rely on what's actually there and the work that you guys do, as opposed to the deficient documents that you were provided in the first place.
I think I got that. So yeah, I'll use that particular example as an example. Is we as a commissioning team are working very closely in accepting the construction of that, or the reconstruction of that, over from the construction department. And while they're doing the installation, they will find problems, TQs. It tends to come to me to answer those. And so we do get involved during the installation stage at finding these problems. And then obviously as we start to find more and more problems, it's right, stop what we're doing. Let me have a better look at this. This seems to be, the design does just not match reality. So we will start going through management and change procedure. Will be, as Stephen said, a lot of technical queries coming through, and we'll go back to the designers and we'll find out a root cause of why these problems happened. And we'll find that they were issued very, very old documents, or they were issued documents that hadn't been updated, for instance. And then that particular board was, right, what's running off it? Do we need it now? It happened to be a lot of emergency sump pumps for flooding and things. So we put mitigation in place of temporary pumps, temporary submersibles, and we switched the board off and basically reversed engineered it. So, and when I say reversed engineered it, it was myself. I went through and marked up all the drawings, and then I got a second one of my APs to go and green line and check all my drawings to make sure I hadn't missed anything. And I had, obviously. And then we'll go through it again together, so on and so forth. We involved the client right the way through this process. And then we sent those back in to the EPC and had them all redrafted. So we had a clean set of drawings. They again were checked to make sure the draftsman had read our red lines correctly. And then we were in a much more comfortable position to start installing on that board again and taking it in through pre-commissioning and commissioning. So I hope that answers the question.
Okay. All right. We're just about at 12:30 now, so that makes it the second best time of the day, lunchtime. So if we just don't rush off yet. Are we having ushers to guide us as well, Angus?
I'll just to say, so a lot of questions come in there.
There's an awful lot of questions, Stephen.
Yeah,
we'll
take the questions off database or spreadsheet.
Yep.
And I'll ask Angus to get the questions to us, and we'll get them typed up.
And I think some
really good ones there that we can answer, which are straight yes or no's, or say we done, or come and find us at lunch break.
Exactly, and I'm conscious of some of them questions will come up in other topics as well.
Could you spend just 2 minutes doing that now? Would you go to the screen and just give
Yeah.
some answers to some questions? Versus that exit or all these?
Quick one. At what voltage is it safe to work live?
I'll put my health and safety hat on and say no voltage, but
Good
that's too
answer.
easy to say.
Okay.
So at some stage, especially on commissioning, you're going to have to test for volts, test phase rotation. So yeah, certainly on AC side, 240, 415, you're going to have some sort of safe system of work for doing that, which will involve proper instruments, tested, calibrated,
Okay.
PPE.
All right. Do you see issues around referencing battery systems above 30 volts DC as high voltage?
Mark?
Come again?
Do you see issues around referencing battery systems above 30 volts DC as high voltage?
Yes.
Now this is
Yes.
Yeah, this is EV market. So we've obviously got some people in from the EV industry here. So I think they're facing a different set of challenges there compared to what you're looking at there, Mark. Okay, other quick, simple ones. What point do you introduce safety rules and safety procedures?
I mean, there's always, for any of the installation work on a substation, sort of mechanical, we do big lifts, so sort of multiple 1,000-ton lifts, so there's always a safe system of work for that. As soon as you introduce power, temporary power, there'll be a safe system of work, so we typically commission through diesel generators for onshore and offshore. As soon as you're ready to energise something, there'll be a safe system of work, either by the contractors, the principal contractors, or we'll bring the client safe system of work in.
Okay. All right. All right, thank you for that, everybody. Great set of questions. Thank you. Thank you. Okay, so we'll take a break for lunch now. We've got an hour for lunch. Okay, back upstairs for lunch. If we head out of the back doors there, we'll go from there. Thank you.